So, Bharat, you have come from Gurgaon, right?
I am. Yes.
Check. So guys, welcome back. And we're just starting with our next speaker, Madan Barabra. He has come all the way from Gurgaon. He's a developer at ThoughtWorks, and he will speak on optimizing your application for the business. So let's start. Thank you, Madan.
Thank you all. Am I audible at the back? Fabulous. Good morning. My name is Manan. Today we'll be talking about how we can optimize our JavaScript code to make it more performant, more user-friendly, more responsive. This talk is going to be, I've basically put in a number of code snippets to explain how things are working and how we can make things better. So I have a number of code snippets inside. That thing below is my Twitter handle, just in case you want to give me feedback. I will also share my GitHub ID a bit later in the app, in the presentation. So one of the questions that I often get asked is, why would you want to optimize your JavaScript apps? Because hey, JavaScript is fast, it is lightning fast, right? Well, primarily one of the reasons why you would want to optimize is because there are already people who have optimized their JavaScript apps, and if the experience that you're offering is anything short of that, people don't generally like that. These are some of the examples of some good single-page applications. It's odd saying the term single-page application now, because if you're building an application today and it is not single-page, I don't know why you're building it today. Might as well have built it a while ago. So every application that you build today is mostly single-page applications. In fact, there are a number of frameworks which help you in setting up a single-page application. Some of the popular ones are listed here. This Angular, Backbone, Ember.js that you might know of. Another reason why you would want to optimize the JavaScript in your application is because you don't want your audience to get this. This is the Google Chrome's crash page. It happens when the process for the current tab runs out of memory. Optimizing your JS apps can actually avoid that problem. In fact, Gmail had the same problem initially when it was launched. Well, it was very responsive and most users did not feel a problem, but there were a number of power users who, while using, faced this issue that Gmail was taking too much of their browser memory. I'd like to begin with some of the misconceptions that people have. The first one is the use of the delete operator. First, I'd like you to understand how objects are stored in JavaScript. When you declare an object, especially for an engine like V8, which is Google Chrome's JavaScript engine, the object is stored as a hidden class. So each time you make any change to the object structure, V8 has to modify the structure of the class itself and then remake the classes. This is highly performant unfriendly or something like that. And we should avoid changing the structure of the object as much as possible. I myself have used the delete operator quite a lot, and some time back I realized that it wasn't best suited for what we are willing to do. What people generally use the delete operator for is to free up some of the memory, which is not what is happening when you use the delete operator. Memory is only freed when the reference that you're clearing out is the last reference to that particular memory. So in that case, it might just do more harm than good. Another operator that people often use is the null, assigning a reference to null. In this code block, I have an object, car, and then I have some block of code in which I do something with the car object. And finally, I say, okay, I'm done, and I want to get this memory freed up, and I say car is equal to null. This is not a way of freeing memory, and it may not always free up memory. We'll come back to this slide. Let's first understand some of the basics of the garbage collector. The garbage collector attempts to reclaim some of the memory that has been allocated. The only way that the garbage collector can know whether a particular piece of memory can be garbage collected is by checking whether it is usable anymore or not. How it does that is it checks whether that particular variable or object is reachable from the window object itself. There was a presentation at Google I/O. It was called a trip down memory lane, which they explain these concepts. I'm pretty fond of that presentation. You can Google it. It's pretty interesting. So they say only if a particular node has no retaining path from the window object is when it will get garbage collected. Let's understand this a bit better. So we have a root node. In that we define an object node. And in that we have something called a scalar node. A scalar node is basically it's a reference which cannot hold, it can only hold reference of one entity. These are your primitive types, your strings, your booleans, your integers and stuff. And these can only be, these can easily be freed up and their reference cannot be moved basically. So if we cut off this path, say we set this particular scalar node's value to null, this memory will be freed up. What happens if I cut this path right here? Can anyone of you, I have chocolates. What? The object is still there. Why? It is no longer reachable from the root node. So it will be garbage collected. But I will give you a chocolate anyway. However, if we had a situation similar to this, for the same object, if we had another path of getting to that object, then cutting off this one reference will not clear up that particular memory. Now let's get back to our previous slide. Again, if in this code block we had assigned another reference to this car object, then setting the car object to null will not free up this memory. So again, another operator that people often don't know what it does. So another golden rule of life, which also holds true for JavaScript, we should not hold on to objects that we no longer need. But since we're talking about constructing new objects and getting rid of old objects, I'd like to talk about singletons. Singleton is a concept that comes from Java, our favorite language. So singletons are basically created once for the entire application to be used later on. But they're not global variables, as in they cannot be directly accessed. They are usually accessed with an accessor function, something like the getInstance method shown here. The getInstance method itself only has one piece of logic. It checks whether the current instance is defined. If it's not defined, then it is created. Next time onwards, this instance is returned and it is not created over and over again. Why would someone want to use this? I mean, what are we getting if we use singletons? Why? What is the benefit we receive by using the same object?
There's an object that represents the screen. There's only one screen available.
Okay.
So my
Correct. So most of you are correct, which is why I am in a trouble of giving chocolates out. So this object is singleton. It is created once. You don't go with the overhead of creating the same object again. There is a bit of heavy lifting that needs to be done every time you do a new object, which doesn't need to be done in this case. It will only be created once. Some frameworks actually have this concept at their very core. Angular, for example, does singletons very well. It uses services, there's providers and there's factories. So that this concept is popular with these frameworks. Something that we need to be wary about is interaction with foreign objects. So JavaScript engines basically compile JavaScript into machine code, which is very fast, it's extremely fast, which is why all the optimizations that we saw about the delete operator, etc., even if you don't do those optimizations, you're fine, because it's fast. But when it comes to interacting with the DOM, or WebSQL, or Canvas, these are entities outside of JavaScript. And if JavaScript has to change those, there is some amount of heavy lifting that needs to be done. And we should avoid these. I know that we cannot avoid interaction with the DOM. That is the only reason why JavaScript is there. But we can reduce such interactions. Yes, correct. I just wanted to put that there because it's what people use. Just wanted it out there. And since the picture had 3 people at So we all use jQuery. Well, most of us use jQuery. This is an example of a selector in jQuery. Using jQuery, now you have an option to come up with extremely selective selectors. So in that, if you want to reach an element, you no longer need that element to be tagged with a particular ID or something, and you can reach it. However, what goes on behind the scenes is not so pretty. jQuery has to go through the DOM, traverse it to find what matches the first criteria, then in another iteration inside that node, then another iteration inside that node, and finally it reaches the element that you're looking for. This is highly inefficient and should be avoided. Instead of that, what we can use is something like this: add an ID to your node and access it. This is much faster since the browser indexes all the IDs that you tag your nodes with. So getting to that element quickly is very much possible using the ID, get by ID. However, this is not always possible, especially in cases when you have a list, you do a repeat on each element in the list, and it is not generally easy to put IDs with each and every element. In that case, something like this is highly efficient. You can scope your search, you can find the nearest node with an ID and search inside it. So this is still much better than what the previous example showed. Okay, another example is we should cache our DOM properties if they're not going to change much. So in this case, if you check, I have a button, and on click of that button, I want to set an element's height. The element is the left element. Now this element's height is to be adjusted according to an element I call the right element. However, with each click, it first finds the height of the right element and sets it to the left element. If I know that the right element's height is not going to change, it makes more sense to cache it beforehand and not recalculate it every time. This is a click event, this will happen at a user action, but if it were a scroll event or a resize event which fires multiple times in succession, this will cause major lag and patchy user interface. Instead of this, you can cache the height of the right element and simply assign it every time to the left element. Another one is to batch your DOM changes. In this case, say I have an element and I wish to set 5 properties of it. I wish to set its height, I wish to set its width, some position, left, top, middle, etc. etc. One way of doing it is this: you set its height, then width, and other things. This will cause 5 re-renderings of the screen. You may not notice it so easily because, well, it's fast. But this is over prolonged usage, this may be a heavy operation to do. Instead of this, what you should use is a batched DOM change. This will only change the re-render the screen once. Even better would be to actually create a class with these properties and simply assign this node that class. That will be even better. See. Sorry. Hello. Event binding. This is some place where we often go wrong and leave space for memory to be leaked. Every time we bind an event, because modern browsers offer you the capability of putting breakpoints and checking what is happening, it is our moral responsibility that we go ahead, put that breakpoint, check whether a particular event is being fired more than once. And if it shouldn't, we should deal with that. There are often cases when you bind a click event multiple times, and even worse is every time some user action is performed, another click event is bound. That is a clear memory leak and should be avoided. We should make sure that the callback function is called once if it is meant to be called only once. The resize, scroll, mouse over events. Can someone tell me what is special about these 3? Why am I categorizing them on one slide? Can you get this chocolate, please? Can someone pass it on? So yes, they fire multiple times in quick succession. The resize event, especially if you even change your screen size by say 10 pixels, it will fire about 150 times. So that would mean the function that is bound to this handler will get called 150 times. You don't necessarily want to do that each time. What can be done? If you have small callback functions, which are generally in-memory functions, which do not involve any DOM interaction, then those functions can be put in, and it's fine even if they execute so many times because they're very fast. If they execute in 2 to 3 milliseconds, you won't even notice any lag. However, if you have DOM changes, it is not always possible for that to execute so quickly. In that case, what is recommended is to use the set timeout function with the clear timeout function, which means each time the event is fired, you start a timer. You don't necessarily have to have a time associated with it, but if another event is fired in quick succession, then the previous timer can be cleared and a new timer can be set. In effect, what you will be doing is for 150 events, you will only be calling the function once. This may not appear very responsive when someone looks at it. I mean, if you're say changing the screen size and nothing happens, and once you stop, that's when something happens. Yeah, but it may not appear as responsive, but it will prevent users from facing a lag after the resize event. This is one way. Another one that I previously showed was to implement some DOM caching. If you can cache some properties, you can prevent a lookup and hence speed up processing. I have this example that I can show. Sorry, I did not have much time to actually prepare a really good looking blog. But what this application basically does is, let's see. You have this button called next post. Click on it. You have some content, and then you have a button to star this. When you click star, some action happens. Okay. So I wanted to use this Chrome DevTools to show you what exactly is going on. Under Chrome DevTools, there is an option to select timeline. Is it not visible? Actually, right now I can keep it here. I can zoom it once I have to show something. Under timeline, if you go to memory, you have an option to say record. So I'm going to start recording what happens with this application. I do a refresh. I go through a usual user flow. Click next post multiple times. And I find an interesting post, I say star. Okay. Say next post, next post. And I stop the recording. I would now like to see how event listeners were behaving, how my application was behaving as a whole. So let's see. So if I see over time, we're only concerned with event listeners right now. So this graph shows the number of event listeners. The graph at the bottom shows the number of event listeners that this application has. So if we increase the duration of the entire workflow, do you notice this? This is a step function. It means that on every user action, we are adding an event listener. This is a clear memory leak. Or on scaling, this may cause your application to be much less responsive. It may even cause your application to crash. We should avoid step functions as much as possible. So let's look at the code base once. I have this. That button is the next post button, and I'm binding a click listener. On click, what it basically does is it removes the old content that was there along with the star button. Then it creates fresh content, adds a star button, and finally appends it to the DOM. That's all it does. What is wrong here? Can anybody tell me what is wrong here? Sorry? Correct. We don't have to create the button every time. The button can reside on the DOM. That would mean only one button, one binding. But say it has to be changed. Every time I bind a new button, I have to insert a new button. If I have to do that, what I also need to do is, apart from removing the previous button from the DOM, I also have to remove its binding from the DOM. So I'll just so all that has changed is that when I'm removing the old content, I added a remove event listener from the previous button. Okay? And going to clear out. And I'm going to begin recording again. I'm basically going through a similar workflow again. Let's see how the curve behaved this time. So as you can see, we have a constant number of listeners, not increasing over time. That graph at the bottom. So as you can see, there's this little uh, thing right there. It means that a previous binding was removed and a new binding was created at the same time. So this is how we can easily avoid such memory leaks. Moving on. So this was the Chrome timeline. I just take a couple of minutes to explain. Down here, you can see whether the DOM count is increasing on every user action. You can see if the listener count is increasing, as I showed. Over here, you can actually see within a time frame what all actions were happening. The yellow ones are the script events. Maybe there were some events, maybe there was a garbage collector event, and a bunch of things that were happening. Over here, you can track different things. You can track how the memory usage was behaving. It gives you a complete graph, how the events were being bound or fired. Okay, another interesting thing was the strings, how browsers handle strings. So JavaScript treats strings as immutable objects, which means once created, they cannot be modified, which is pretty similar to other languages as well. Now, a simple string concatenation of 4 strings that we have here, how the browser actually interprets it is somewhat like this. It takes the first 2 strings, concatenates them, finds it, prepares a third string, then it takes the next string, concatenates, creates a new string. So if you have a number of strings, this can lead to a performance bottleneck as well. Especially browsers such as Internet Explorer 6 had faced this problem. It was a very serious problem for them. It caused a major memory bottleneck and apps becoming non-performant. So instead of doing string concatenation using the plus operator, it is generally advised to use the native join operation. You can keep pushing your strings into an array, which is again a very fast operation, and finally do a join on them to get whatever you wanted. It is said that the worst place to leak memory is inside a closure. Closures are functions that return functions inside them, because there may be cases when you want to call a function based on the context that that function is in. In this case, hello? In this case, can someone tell me whether after the execution of this block, and say I'm using the variable a elsewhere, after execution of this block, will the variable large str be garbage collected? Can one of you tell me why? Reference. Correct. Because large str can still be reached by doing a call, right? Which is why such a huge string will not be garbage collected. Maybe there is a better alternative that can be looked at, and such are the cases when you should consider revisiting your code base. This is another interesting example. Timers. Who likes timers? Yeah, me too. Love them. So, I have this example. It's better if I actually show you a running example. So I'm here, and visible. So I have this object. It has a function called me, and then inside that function, I set a timer, and every 1 second, this will print time is running out. So I execute this. You can see that every second, there's a log happening in memory. Now, I have, what happens if I take this my obj? I want to stop this timer. Can someone tell me how? Can I take this object, set it to null? How do I clear the timeout function? Send call me to an empty function. Lovely, fabulous. You deserve more chocolates than one, man. Anyway, whenever you get a chance. So yes, that is one way. But what if I set it to null? If I set this object to null, now there is no way of actually clearing out this timer. The timer will still keep running, and you've lost every reference that you had. but since it's inside a timer, it has an everlasting reference. So this is another place where you can avoid bottlenecks. Alright, moving on. I'm actually done with the presentation. There's just this one last thing I wanted to spend some time explaining what I know about the Chrome DevTools or the Chrome console. I showed you the timeline graph. I have this huge form. You don't need to read the form itself. It is basically an open source application that I'm working on. So it has this huge table, and I want to profile it. I want to see how it behaves. Alright, so I say I want to see what all events are happening, and I say record. So I've scrolled, there is a header changes, I scroll up, there's a horizontal scroll bar that I get, I click here, I switch a tab, come back. Okay, this seems to be an ideal flow. I will stop recording. Let's just take a couple of minutes to analyze what we have. Okay, so this is your window over here. There's one bar here, one bar here. You can slide it according to your vision, see what is happening. So the yellow blocks are script events, JavaScript events that you've bound or functions that are getting executed. Green one is the screen painting that the browser is doing when it needs to repaint, when certain change in CSS happens. Rendering is a more heavy operation. It re-renders the DOM itself. One interesting, so you have all the events or everything that happened in this time frame in this side nav over here. If I increase this window, I actually wanted to show. So if I have, so this particular one, can everybody read this? This is the GC event. It means at this point, garbage collection happened. As you can see, it's actually very random when garbage collection happens, which is when you should think about using singletons and stuff. Because you can never predict the behavior of the garbage collector. When a particular memory will be garbage collected is not under your control, and you can't generally force the garbage collector to collect some memory. One more thing that you should be using is the profiler, especially the heap snapshot. So this can also be used. You can say take snapshot of the current state. It will tell you how much memory this particular page is occupying at the moment. There's 13.9 megabytes is occupied. And then you can do some action. And you can take another heap snapshot. So as long as the difference between your previous snapshot and the next snapshot in a general workflow is 0.1 megabyte, it depends on the context majorly. But if it is leaking like 10 megabytes or 6 megabytes, that is a cause of concern. You should then start considering optimizations in your application. I was looking at Gmail yesterday. It turns out that for a general operation, it was basically leaking like 7-8 megabytes of memory. But after a while, running the application, it came down back below. So I'm thinking that after a while, they actually do a check in their code base and make optimizations as and when needed. But yeah, so this is another thing that people should be checking. Yes? For that?
They are following the best practices, but they are generating a lot of memory usage. So, since that memory usage is being generated, hence you see the after, but since they are using the best practices and figuring them out how to. So, in short, they are generating a lot of memory usage, but they are laying it out, and only when the GC happens does that get together.
Fabulous. But say you wanted to create memory in a very short span of time. You can't rely on the garbage collector. So in that scenario, it is better to clear out memory yourself if you can, or not assign it too much memory in the first place. But yes, you're right. I think that is what they're doing. Because they need to assign a lot of memory, they do that and finally end up clearing it later. That is correct. That is it from my side. That's my Twitter handle. Thanks a lot.
Thank you, Bharat. Would you like to take some questions?
That would be if you have any questions.
Yes. Questions? Yes.
So I actually wanted you to do a course CC on that, what example you have shown now. You were adding a lot of event handlers when you click on that, and you are doing some others. And actually want to know whether in force CC, I think moderate developers are starting to find out or to remove all the event handlers which are not in the law.
I would say they should be intelligent enough. But
I think you just need to do a force CC and see that its graph is coming down or not.
okay, I mean that could be correct, but can't expect your users to do that.
I think, but it still breaks on the older version of IE.
Sorry,
That is still a problem in older version of IE.
that is true. Uh, Even browsers, but some of the libraries that you use, say you use jQuery or something, when you call a remove using jQuery, then jQuery actually internally handles this operation of removing all the bindings of all the nodes inside that chunk that you're removing. But if you use standard HTML, then obviously, as far as I know, the browsers don't do it themselves.
I think modern version does that.
We saw, but maybe yes, they should be doing at least.
Right. Are you aware of any browser-specific optimizations that may need to be done in certain applications? Because most developers tend to use Chrome because it's fast and developer tools are awesome. But I have noticed certain cases where the website is generally, web application is generally slower on Firefox or IE or Safari. Now I'm not sure if it's because of the browser itself or there may be something which you can do.
That string example that we were taking, did you see the join that we did? So that used to have, so Firefox and Chrome, since the very initial days, they had implemented the plus operator to work in a more efficient way than IE, which is why people face this problem majorly on IE, which is when it was suggested that instead of that, you should use native operations such as joins, etc. There are many more optimizations which are very browser specific. But I would say more than browser-specific in-memory optimizations, they cause little memory leaks. What majorly causes memory leaks is your DOM handling and your event bindings, which mostly are common across all browsers. But yeah, it wouldn't hurt to explore more on browser-specific sites as well. Yes? I can't hear you, sorry.
Sometimes memories happens most of the like when the application is coming, I did like more of that. So same application, the single page application. So the same application is when it is open for like hours, some application, then the memory leaks is more dangerous. So is there any way to automate or something so that you check continuously and find it?
So you need to ask in those hours, is there anything happening that is outside of the regular user flow, which generally won't happen. User would generally, if it's an email client, he would be opening emails, he would be receiving emails, which you do not need to automate over a lengthy period of time. You can see that if a new email comes in and he opens it, you can see if any memory, you're right, it is difficult to detect a memory leak in case it only happens over time. But with the modern tools such as the Chrome Dev tools, it is now very easy. You can even see if one event listener was added. So it is easier to detect it even in a small time frame. But some of the problems, as you say, may happen over time. And
like instead of we by ourselves doing this thing, it is like some memory like that. So you saw step, right?
yes,
In case of that, like there must difference is there. Is other thing or something different.
would be a very nice to have. I would need to explore, but it would be great if we have something.
Thanks.
I think that's the last question we can take. Okay, this is the last question for you. So this is something that I'm trying to explore. Like as we said, single-page applications are preferred more because it keeps the user more connected with the page. It doesn't have to be
Generally more responsive.
right now. The problem with single-page applications, like when the user keeps getting more content, it will generate more elements in the page. Let's say the number of users will also increase. Now, if the page was to reload, all that will be collected. It will be like a fresh page, and only those things which have to be shown will be loaded, right?
Correct.
Now, comparing that with a traditional website, the problem is that it has to load all those each time. Now, you might have heard about HTML like app caching.
Yes.
Let's take a case of some kind of offline apps. Offline apps will basically cache all the HTML fields and all the resources inside the browser, so that it doesn't have to go to the server to load it all the time.
No, that.
No,
Complete your question.
For example, an example is that Gmail offline. Yeah, seen that. It's like
Yes.
Now, the question is basically, what if we reload that an offline page for each app?
So it basically depends on how you're implementing your offline page, but you need to know.
This is a general question, as in like.
Yes.
I'm not
So
asking you
the page can be a static page that only has some content rendered inside the DOM itself, in the HTML itself, that is. Or you could have a JS generating your DOM in that case as well, in which case it is no different than your internet-based application. Your offline and your internet-based application are no different, because in any case, you're getting certain elements and you're rendering it on the DOM on the client side itself.
I'm caching all that. I have all my libraries.
No, you're caching, but you're not loading them into memory. You are caching them. They're on your machine, but they're not loaded on your
The
browser.
question was basically regarding, let's say, typing garbage by reload.
Okay.
And in the sense, it's an offline page. It doesn't have to load the content from the server. I think like
Loading the content from the server is not the issue. Loading the content into the browser console, rendering it on the screen is the issue. So as long as it is in your computer, it's not hurting you.
I think maybe I'm not asking the question, or maybe I'm not able to get the question.
Okay.
Now, the thing is, like the single page application, as we keep using it, we'll have more elements coming into the page.
Okay.
That's not right.
Not necessarily, but okay.
Maybe. And again, the resources used will also increase. Maybe not that happen. Now, what happens if page reloads? All that memory will be freed up, right?
Of course, all the DOM nodes will be garbage collected.
Now, that is what happens in the traditional page.
Yes.
Now, the problem with traditional page is that each time it has to load all the HTML libraries that it produces everything on the server.
That. So is
So if it cached all that,
yes.
and then we reload it from the cache, would that be better than having?
So I understood your question before as well. So my answer to that is, it is on your machine, it is cached, yes, but it is not loaded on the browser window itself. Every time you reload, it is looked up from the cache, and that is when all the memory issues start happening.
That's the first part. As in that the page is setting up. The page is setting up. For example, even if you use Gmail, initially it loads some parts of it. Like in case of Facebook, it loads the top part first. Then it loads the content. Right? Now all that top part will be cached. So each time you reload the page, the HTML page is set up. Then it sends the request to the server to get the data and then pop it. How about that?
Yeah, I think Manan is available offline.
Yeah, let's. Can we take this offline? I would
I
love to.
think this warrants a longer discussion. So you can catch another 20 minutes. So thanks. That's it. So thank you.
Thank you, everyone. Thanks a lot.
So our next speaker is Nikhil Mitchell. We'll be talking on the Harmony ES6, which is the next JavaScript version. And while he sets this up, let me ask you another JS one.